In today's video, we will determine what is the relationship between these two pairs of cyclohexanes, diastereomer and enantiomer, identical or constitutional isomers. So, given that the two substituents are not directly opposite of each other, that means it is not an automatic diastereomer because any cyclo compound that has two branches directly opposite, whether cis or trans, is going to be a diastereomer. So then we will have to look at the chiral centers and assign R or the S configuration, and also assign the carbon number that has a R or the S. And we'll call this carbon reference number 1. So the other one must be carbon reference number 2, which has an S configuration. Now at the bottom here, we want to find out if R is still on carbon 1. So we can tell that there has been a ring flip that happened because of the difference in direction. So now we determine how much each of these moved by. So a ring flip is going to go clockwise if you start from this form of a chair. So then that means if our carbon reference number 2 is here, this is carbon reference number 1. So let's move it by 2, 1, 2, 3. Okay, so we hopped by 3. Let's do this. 1, 2, 3. Okay. So that must mean this is our carbon reference number 1, and this is our carbon reference number 2. Now it can look a little bit counterintuitive because you see 1 is in the front and then 2 is in the back, and then you see, oh, now somehow 1 is in the back and then 2 is in the front. But it actually makes sense because if you're going clockwise, 2 is actually already in the front. So just be aware of that. That means in our bottom molecule here, it is still 1R2S. So these two are identical. For this question, so let's determine the chiral centers and their rotational configurations. So this is an S direction, this is an R direction, this is an R direction, this is an S direction. But do not be fooled, they are not identical because there has been a chair flip. There has been a ring flip. Okay, so you can tell a ring flip because they are like in opposite directions or parallel lines. So then here let's give it a reference carbon number. Let's call this one 1 and let's call this one 3 because it's on carbon 3. Now on the top, we want to know if carbon 1 still has an S configuration. So we have to do our ring flip. If we're going to go from the bottom to the top, everything's going to go clockwise. So let's do this. Okay, so we're gonna go, this is our carbon 1. Let's see where it will end up. Okay, so actually there's a hack for this one. Because these two are different directions, we know that if something is up, it's gonna stay up throughout the entire ring, no matter axial or equatorial. So we can immediately tell that if this is down, so no matter where it is in the ring, it must still stay down. So this is going to be our carbon reference number 1. And we can tell that carbon 1 now has an R configuration. Therefore, the S must be due to carbon 3. And because we see that R has changed to S and S has changed to R, both of these chiral centers have changed their configurations. That means these two are enantiomers. Now the big takeaway here is that in question H, it's easier because you can infer by their up and down directions to determine which configuration is on carbon 1 or 2. But in I, it was a bit more tricky because you had to actually do a ring flip and then do the counting. Just be careful for that.